So June 25th, 2019, I spent a couple of days at Oceanside in Carlsbad, just south of, between LA and San Diego, a couple of days after the bash. An annual trip, it seems, is to the Miniature Craftsmanship Museum at Carlsbad, and a few new exhibits that I hadn't seen before. And this is just a quick video to see what sort of grabbed my interest. This little whole book lathe in 1/6 size, made by English gentlemen. It's a beautiful piece of craftsmanship, all castings and fully machined. Everything works. 20 years on, it's stood up pretty well. I don't think it's done a lot of hard machining. But that is a new exhibit that jumped out at me as I walked in the door, and I had to spend a little bit of time spending it, just checking that out, because it's a beautiful thing. The erector set display cabinet often changes, and last time I think there's a locomotive in here. Now there's this time there was a erector set fire engine, 2 or 3 complete sets of the same model of different ages. It's really nice, and an assembled fire engine there. It's pretty cool stuff. I always like to have a look in this cabinet and see what's changed. This Bucyrus steam shovel is a regular attraction for me. I really wanted to spend a little bit more time with it and just have a bit of a look. Not ever going to be a complete future project for me, but this really is a very inspiring model. It's quite large scale, but I imagine everything works. It's got all the proper fittings and swivel fittings and everything on there to make the engine on the boom work, and lots of really nice details. I can't help just being drawn to that model. Another machine tool that everyone sees pictures of and no one knows much about is Mr. Jordan's Bridgeport mill. He made that from memory without any dimensions much, and it's not a bad effort at all. It's such a pretty little machine, and it's only about probably 8-10 inches tall. It's always an attraction, and I'm glad it's still on display. Lots of other little things too. Stationary engines. There's so many things hidden away, and you could just spend all day here looking at things in the cabinets. These Corsair fighter planes, Navy fighter planes, are crazy amount of detail. They're all made out of metal and cut away. I'm just in awe of the craftsmanship in these. It's like a plastic FX model, only it's made out of aluminium and stainless steel. They're crazy things. They're well worth a look. These model race cars capture anyone's attention, I think. They're beautifully made. Leather seats and wooden steering wheels, and properly painted and polished, little running engines in them. These are quite big, but they're beautiful models, and it's awe-inspiring to look at things like this and wonder how many years people took to actually build them, and what they were even thinking when they started, because it's a crazy project. This is the world's smallest diesel aeroplane engine there. It's not very big, about 7/8 of an inch long. I'm not sure if I got details on the prop size, but it's not a very big engine, and to see this amongst some of the bigger models is crazy what people do. 0.0037, I think, cubic inches. something here for everyone. You've got to make the trip, and you've got to go and have a look. The other side of that car.
Yeah, Bob gets a commission for his autograph or something. So, this is a conventional machine shop, no computers. The only machine in here that works on a computer is that 3D printer over there. And right now it's waiting for me to fix it. It does not fix itself. So we're going to run some little engines for you. We're going to go over and talk about this device first. This was put together by the gentleman you see in the picture above it. He worked on this thing for, better part of 20 years, from the late 1940s on up into the 60s. He was a landscaper up in the Los Angeles area, but he had a hobby. He liked to work on clocks. He liked to buy old clocks and tinker with them, try to get them up and going. He called this his do-nothing machine. Now that motor drives it around and around like a merry-go-round. He's using a flat chain called a ladder chain and a sprocket that meshes with the pitch of the chain. This is a method they used back in the 1920s and 30s to turn stages in theaters. You did not necessarily need a gigantic gear, you needed a chain and a sprocket. Up here you have a track that's actuated by 3 cams. 2 of these cams are going to go to the high point, 1 at the low point. That will create a bit of a slope in the track, and by gravity the ball is going to run downhill. Here's the heart of it right there. I'm pointing with the laser. That goes down to the base. That is a component from a Norden bomb sight from the Second World War. The Norden bomb sight was a mechanical computer manufactured by Sperry Gyroscope, and they were used in our bombers to aid them in precision bombing from 30 or 40,000 feet. And they were a top secret device during the war. World War's over about 1945, comes along 1947 or so, the Air Force determined that these things were obsolete, so they should scrap them, get rid of them. He found that in a surplus store, and then he started adding all this other stuff, the chains and the sprockets and the gears. Look at here, here's a round gear driving a square gear and an oval gear. Kind of an unusual setup. And then the red light, he put that on in the mid-1950s. And he was telling people that this thing is actually a flying saucer detector. So if that red light goes on, there's a flying saucer in the area. Now the machine has been here, 7 years plus. The light's never gone on. I guess there's no flying saucers around. Now there could be another reason. It's really nothing more than a bike light. So I just don't put batteries in it because it's something else to maintain. The 2 switches you see down there control the 2 upper motors, that one over there and the one tucked away inside here. Because when something jams up on this thing, I have to fix it. So I can turn one motor or the other off and trace out where the problem may be by eliminating one motor or the other.
How often does it jam up?
It's been pretty good actually, because I've been lubricating it every Saturday. I spritz it with silicone spray, and that seems to be keeping things running pretty smooth. I went on vacation in May. I came back, there was a part not working. It took me about 2 hours to figure out and correct what was going on. There we have a bunch of bevel gears. They allow you to transmit power at a right angle. So there's a lot of things going on. We get some very interesting comments about it. Had a gentleman who I think summed it up pretty well. He said, what we have here is motion. We have movement, and it makes noise. But it really doesn't do much of anything. You see the similarities to Congress here? But it doesn't spend money. Now, here's an interesting. It's known as a hit and miss. Now it gets the name from the sound it makes when it's running. It's not going to sound like a lawnmower with it. Spinning the flywheels converts to a radial energy. Here's a pulley. Let's say back here we're going to run a sawmill. So we run a belt from here back to our sawmill. The engine gets its electrical energy from a battery. We have a battery and a coil. We have a wire that comes to this device right here. This is what's called a controller for the points. Now, This engine does not have spark plugs, but inside the intake manifold, which is right here, which accepts fuel from the carburetor in a mist form, is a set of contact points. So when the governor, which is controlled by this mechanism through all this linkage, determines that the engine needs a fire because it's slowing down, this little pole comes up and trips that device right there. That opens fuel. So you don't really have a spark plug. So let's turn it on and let's get it running. That's going to sound like it needs a tune-up, but it doesn't. That's just the way it fires. It only fires when it needs to. So these engines like this could run all day long on very little fuel. Many times they're pumping water. Many times they're pumping oil. Running a sawmill, running a combine, anything. Now if you put a load on it, it's going to slow down, but it's going to fire more often. Because the governor is sensing it's slowing down, it's going to just activate that spark more often. It'll draw more fuel and it'll fire. And I'm not going to run it very long because we're producing exhaust gas.
So how does it know to speed up or slow down?
How does it know?
Is it counting revolutions right there?
No, it's actually a friction clutch.
Okay.
So as it slows down, the friction becomes greater because the clutch segments pull together. That activates the rod, and that opens up the points. Okay, that's an internal combustion engine. Means our heat source is taking place inside the cylinder. Over here we have an engine from the 1840s known as a Stirling Engine. It was invented by a Scottish minister about 1840. Initially they would use to pump water at the coal mines. Before that you had 10-year-old kids operating hand pumps. Now here's the way this works. It's a closed system, no intake or exhaust. In that chamber we're heating the air, we're causing the air to expand. When it does, it pushes the piston in the cylinder back toward me. Now when the piston reaches the extent of its travel, when that connecting rod is all the way out, that allows the hot air to vent through a hole into this canister. The canister has fins on it to give off heat. In giving off heat, we're going to cool the air in that canister down. It's going to condense it. It's going to create a vacuum. The vacuum is going to travel through this tube into this cylinder. The vacuum in that cylinder is drawing that piston that way. The pressure in this one is pushing this piston this way. So you have two pistons going in two different directions. But to transfer the power, the pistons are connected up 90 degrees apart to these flywheels. Here's a pulley. We can run a belt to whatever we want to run. So this piston is pushing, this piston is pulling, and there it goes. That's an 1840 invention. And you look at that and you figure this is technology we've certainly forgotten about. It's not the case. Between here and Arizona, there's a generating station. To run the pumps, to cool down their generating equipment, they use Stirling engines. Now they're more sophisticated than this one. This is
So here we are nearly a month later, and I've been a bit slack with videos this last little while, but there's a bit going on and I've had bronchitis and stuff like that. But I'm back and at the Bash swap meet, and I think I may have already shown this, but I picked up this engine set of a gentleman named Roger Taylor who lives very close by, and I actually ran into him at the Miniature Craftsmanship Museum. This is some short footage of an engine designed by Paul Breisch, or Breisch in America, probably in the 90s. And the engine I bought off Roger Taylor was a air-cooled version of that. We've got an air-cooled cylinder, and a cast iron crankcase is a really nice casting, and a half completed crankshaft, 2 flywheels, and in here we've got a cylinder head, and the two main bearing journals, caps, main bearings, a piston half machined, the timing gears, some springs, etc, etc, pieces cut out for the cam. So pick this up. I'm not sure whether I'm ever going to finish this. He was kind enough to send on the drawings, which went with the model at the swap meet, at the bash. But there's a fair bit of work in this engine, even compared to the big one that I'm working on at the moment. It's quite comprehensive, and there's a lot of small parts. This is the air-cooled one with the fan and the pulley. The carburetor is quite complicated, and the ignition, fuel system. How to make one-piece crankshaft, spark plugs, and the main drawings, which show that there's still a fair bit to be done even on the main parts. There's flywheels that still need a little bit of work, the cylinder head which needs quite a lot of work, the main body which needs a fair bit of work, piston needs a fair bit of work. We need a brass conrod, and on the second drawing there's the crankshaft and tappets, cams, things like that. So a lot of work in this little engine, and it is pretty microscopic work. It's really quite tiny. Not sure if I'm going to ever finish it or complete it or even make a start on it, but at the price I paid, thanks Roger, I really appreciate you doing that. And we'll see what happens with this. But I just thought I'd put that in as an asides or a finish off on this video. Thanks for watching. Don't forget to like and subscribe, and be kind to each other. That's fairly important. Don't comment on the political joke in there. I left it in there because some of you guys will think it's funny. If you're triggered by it, don't comment. I really don't care. And well, absolutely I care, but if you're going to leave a comment, leave it on something else. We better get back in the workshop and actually make something so we've got some real content.